Hello everyone, my name is Jungkeun from AIX School. The title of my presentation today is Adaptive Method for Handling Missing Data in Streaming Medical Signals. You can think of this as methodological support to help researchers perform better in the field of medical engineering. Here is the agenda for today's presentation. As you can see, this is how the talk is organized. Now, let me explain what streamed longitudinal data means. Streamed longitudinal data refers to data that is generated and transmitted in real time from various sources, but it is different from traditional longitudinal data in several important ways. First, traditional longitudinal data is usually collected at fixed time intervals and stored in batches, but streamed longitudinal data comes in continuously in real time, often with irregular time intervals and inconsistent data quality. Second, traditional longitudinal data is often analyzed after all the data has been collected. But for streamed data, we need to process it in real time as it arrives. So if there is any missing data, we need to handle it immediately, for example, by using real-time imputation. We can summarize these differences in the table shown here. And missing values are a common problem in streaming data. This can happen due to device malfunctions, network problems, or user errors. That's why we need real-time missing data handling method to keep data analysis valid even while the data keeps coming in. If you look at this figure, you can see missing values can occur in different ways. For example, within a single medical signal, missing data might occur at specific time points like this, or across entire segment like this. And if you look at multiple signals together, missingness may appear randomly like this, or in specific patterns that are not random like this. We can better understand the impact of missing data by looking at from two perspectives, that of the data analyst and the data producer. From the data analyst point of view, when missing values occur, it becomes harder to process, manage, and analyze the data effectively. If we don't use proper method to handle the missing values, the analysis can become unreliable and it may lead to wrong or misleading conclusions. From the data producer's point of view, if missing data is not properly handled, it reduces the completeness and usability of the dataset. This becomes a serious obstacles in the entire data pipeline from the data collection to analysis and decision making. Unfortunately, the development of statistical method for handling streaming data has been slow, so it's not surprising that statistical method for missing data in real-time settings are also underdeveloped and need much more research. Now, if you look at the figure on the right side of this slide, this comes from a real-world study using biometric real-time signals. You can see the data processing flow here. The researchers defined what missing data is, and they exclude some subject if the missingness is too severe, like this. But this also means that even among the selected subject, missing values still exist and need to be handled during analysis. The goal of this study is to handle missing data in large-scale, real-time streaming environments, but more importantly, our aim is to develop a method that can work in real time. In other words, a method can method that can process missing data as the data streams in. To make this possible, the method must be computationally lightweight and flexible, meaning it can adapt to different patterns of missing data by observing the data itself. Of course, this is a very challenging task, and let's briefly compare this with more traditional method. Most existing studies on missing data, like imputation method, focus on retrospective replacement, that is, handling missing values after all data has been collected. A typical example is electronic medical records (EMR). In contrast, this study focuses on developing a statistical methodology that works in real time, specifically for streaming data, and aims to support real time statistical inference. The key focus of this study is building a strong latent representation. A latent representation is a compressed summary of the complex structure in original data. We aim to use this compressed representation to automatically solve missing data problems in real time. There are several types of latent representation. In my opinion, using an autoencoder effectively can help us solve missing data issues in multimodal or large scale streaming data in real time. As shown here, an autoencoder is a type of neural network used to learn an efficient representation of data. It works by encoding the data into a lower dimensional form and then reconstructing it. In the case of multimodal data, we can improve performance by identifying cross dependencies between different modalities of or variables. This means we must consider these dependencies to make the most of latent representation. Ultimately, the goal is to include all these different types of data and their relationship into a single latent space. In this way, the information can be used effectively when needed without storing everything in memory. The figure on the right side shows an example of multimodal data. Again, the key challenge is capturing the different characteristics and correlation of these various data types in the latent space, and then lightening the inference process to make it efficient and scalable. Theoretical proofs and simulation studies are not expected to pose significant difficulties, but obtaining real world medical data may be challenging, and developing lightweight algorithm design would be essential part. Lastly, for solving this problem, it is important to get a strong collaborative network among researchers. The outcomes of this study can be broadly applied to real-time processing of medical data. Furthermore, the proposed methods are expected to be effective even for large-scale streaming data without computational bottleneck. Ultimately, the study is anticipated to contribute to various industries where stream medical data is utilized. This is the end of my presentation, and thank you for attention.